So that's why when I was going through this first slide, I told you that the two signals with same phase and same frequency. Why same phase also? Because you see or you compare the amplitude or the shape of the signal at 0 point. Okay, पहले में 0 में भी start हो रहा था. Okay, तो second में भी वही 0 में start हो रहा है. Okay, और पहला वाला T/4 में peak हो रहा है और second वाला signal that is also getting peak at T/4. Okay, so that's why both the signal are having same phase and same frequency, but their amplitude is different. In the second example, here the frequency is different, but you can say the amplitude is same as well as phase is same. The third signal, their frequency is mostly same, frequency is same, as well as their amplitude is also same, the phase is different. Okay. Right. Next, we'll see about the periodic and non-periodic signal. Okay. So what is periodic signal? As it is saying, a continuous time signal xt is said to be periodic if it satisfies the following property. What is those property? Yes. First one, xt must be everlasting signal. Everlasting signal means what? It is lasting always, or it exists from t equal to minus infinite to infinite. Okay, हमेशा वो signal रहेगा. Okay, that signal is not for a, let us say, from 0 to 5 seconds the signal is there, and after that signal is not there. It is not like that. Okay, if that signal should be existing from minus infinite to infinite time. Second condition is what? xt of xt equal to xt of t plus n t0. Okay, that means it should be repeated after a certain interval. Okay, for all t for some positive constant t0. We'll see that with some example. Okay. So can you give me one example of a periodic signal?
Sin x,
Yes.
cos x.
Sine wave or cos wave. Okay. And what
All
is
the
the period?
trigonometry functions, sir.
Yes. So what is the period of sine wave?
2 pi.
Pi, sir. 2 pi,
2
sir.
pi, 2 pi.
2
2
pi,
pi, not pi. Okay, it is 2 pi.
Yes, sir. 2 pi, 2 pi.
Okay. So if I'll say the period of this sinusoidal wave is 4 pi, is it right or wrong?
Wrong, sir, but because it's rotated two complete rotation at 4 pi.
Okay. Have you heard about the fundamental period and the period only?
Yes, sir.
Yes, sir.
Yes,
2
sir.
pi is the fundamental period, and periods can be any multiple of the fundamental period.
Yes, period is any multiple of fundamental period. Then which
Yes,
is
sir.
fundamental period and which is period?
So period is the
No.
minimum.
In the right. In that example, in sine wave, okay, what is the period? What may be the
Sine
period?
wave 2 pi is the fundamental period, and 4 pi, 6 pi, 8 pi are
Right,
the normal periods.
right. So as that is also mathematically represented in this condition, which is written over there, xt equal to xt plus nt0. Capital T0 means it is, let us say, one constant. Okay, and this n is some integer. Okay, so okay, otherwise if it is not satisfied, then this is called as a non-periodic signal. Okay, I'll go with an example with that. Okay, for any periodic signal, the smallest positive value of t0 that satisfy the periodicity condition is called as fundamental period. Just a minute. Okay, so let us talk about a sinusoidal wave t. Okay, so here Okay, x of t equal to x of t plus 2 pi. Yes or no? Because if it is a sinusoidal wave, okay, let us say sin x, okay, sin x, okay, is also equal to sin x plus 2 pi. Okay, you check with any value of x. Okay, so that will be satisfied. Okay, so that means here 2 pi may be one period of the sinusoidal wave. Instead of 2 pi, if I take 4 pi, then also it will satisfy the condition sin x equal to sin x plus 4 pi. That will also satisfy. Yes or no? Is it satisfying? Because you take, let us say, x equal to 0. Okay, so sin 0, is it equal to sin 0 plus 4 pi? Suppose we will check with this thing. Let us say x equal to 0. Okay, if x equal to 0, then left side is sin 0, right side में sin 0 plus 4 pi. Okay, are they same? sin 0 का वैल्यू भी 0 है और sin 4 pi का वैल्यू भी कितना है? 0 है. Okay, sin 0 is also equal to 0 and sin 0 plus 4 pi. Okay, so that is also equal to 0. Both are same. You can also check with any other value of x. Okay, so that will satisfy. Okay, so here this 4 pi can be termed as a period of a sinusoidal wave. Okay, but as the name indicates, the smallest possible value of t0, okay, which satisfy the periodic condition, is called as the fundamental period. Okay, तो कौन सा स्मॉलेस्ट वैल्यू है? 2 पाई से कोई, यस, 2 पाई से कोई छोटा वैल्यू है जो कि पीरियोडिसिटी कंडीशन सेटिस्फाई कर रहे हैं साइन वेव में?
No, sir.
No. Okay, because sine wave is repeating after 2 pi. Okay, so that's why the 2 pi is the minimum value. Okay, so 2 pi is the fundamental period of a sinusoidal wave. Okay, so I can also say that 4 pi is satisfying because sin x plus sin x equal to sin x plus 4 pi. Okay, so that means 4 pi can be termed as a period of a sine wave. Okay, but the fundamental period is 2 pi. Okay, so any multiple of any integral multiple of the fundamental period is the period of a signal. Okay, so that two the things are just represented in this slide. A continuous signal xt is periodic if satisfy the following conditions. So first one is xt should be from minus infinite to infinite. That signal should last from throughout the condition, throughout the time period. And the second one is it should, I mean the second condition, xt equal to xt plus n t0. Okay. Right. So let us say here you just don't read this thing. Just tell me which figure is periodic and which figure is non-periodic.
First, third, and fourth are periodic.
First A, C, D.
A, C, D.
A, C, D. Okay, those are periodic. Okay. First one is let us say we'll start with figure A. Figure A
Sine
is,
inverse of x.
we'll see that. Okay. Figure A, is it satisfying both the condition? Is it lasting from minus infinite to infinite? Yes. Here it is shown little bit portion, but since I mean you are observing that I mean at this point nothing is, I mean graph is not there, that means it indicates it is there from minus infinite to infinite. Second is it repeating at a certain interval? Yes, it is repeating because you see, okay, so this same portion or same thing is again repeated. Okay, so both the conditions are satisfied, so this is periodic. Okay. The second one, B, option B. Okay. Option B. Is it from minus infinite to infinite? Yes. Okay, because I mean, at this point, it is exponentially decaying curve. Okay, so it is going, it will go till minus infinite, as well as in the right side, it will go till plus infinite. Okay, but whether it will satisfy the second condition, that means whether it will repeat.
No.
No, it will not.
Non-periodic function, sir.
It will not
No, sir.
repeat itself. Okay, so it is non-periodic.
No.
Non-periodic. Third one, option C.
So not
Periodic,
everlasting.
periodic.
Yes, any problem?
Sir, C is ending, not everlasting.
No, C is also everlasting. You
Sir,
see,
C is periodic function.
yes, C is periodic. Okay, I'm talking about option C. Okay, so here it is. I mean, figure will obviously shown a little person. Okay, so here it is after minus 2 also the curve is there like this. Okay, so that means it is satisfying from minus infinity to infinity is there, and also it is repeating following the second condition. Okay, so this person is again being repeated. Okay, so that's why it is also periodic. Option D.
Non-periodic.
Yes, option D is non-periodic because see in this figure
Because
it is
only one side,
yes,
positive side of x-axis.
you just mark here in this figure, the left side is already shown, which are, I mean, for these points I don't have value. Okay, these are all are 0. It means the signal is not lasting in the negative side. Okay, signal is starting from 0 to, let's say, infinite. Okay, it may go up to infinite. Okay, it means the first condition is not satisfied. Okay, so if it is not lasting from minus infinite to infinite, then it is non-periodic. So it is non-periodic. Okay. Then we should be a little bit familiar with different terms. Okay, like what is angular frequency, and phase. Though we have seen what are their physical significance, if it is how it is written in equation form and how to find out those things, that we should be familiar with. So normally the first line xt equal to a sine omega 0 t plus phi plus theta. Okay, so that is the way in which the signals are represented. Okay, so here the terms A is amplitude. Okay, omega 0 is the angular frequency. Okay, and you know angular frequency is written in terms of 2 pi f. Okay, so if you know the angular frequency, you can also calculate how much is the frequency. Okay, so this f you can calculate. Next, you can this theta is the phase of the angle, phase of the signal. Phase means how much it has been delayed or how much it has been lagging or leading. Just one example I'll just show, then I'll stop here. Okay. So in this problem 1, problem A, can you tell me how much is the amplitude?
5.
Okay, before doing this, I'll just write down the formula, otherwise it will be more easy for you to understand. Okay. Yes, 1 minute. Just I'll finish it. I think next class is consultancy. Yeah?
Yes, sir. Yes, sir.
Yes, just let me finish it quickly. Just then I'll leave you. Okay. S and omega 0 t plus 5. Okay, just you have to compare with this formula. Okay. So A means amplitude is equal to 5. Then your omega 0 or angular frequency is how much?
200 pi.
100 pi. So if omega 0, you know, omega 0 is equal to how much? It is nothing but equal to
2
2
pi
pi
f.
f.
2 pi f. Same place f equal to
100 hertz.
100. Okay, and phi equal to, in this problem, phi equal to how much?
0.
0.
0, because
0.
here it is nothing written. If let's say something is written like 200 pi plus pi by 4, it is written like this. Okay, so then in that case the phi would be how much?
5 by 4.
Yes,
Pi by 4.
yes, whatever is written plus omega 0 t plus whatever written, that is your phi. Okay, and the second question, okay, this one is done. Second question, tell me how much will be the amplitude?
2.
It will be minus 2 or plus 2?
Plus 2.
Plus 2. Plus 2.
Yes, always the amplitude will be plus, because if I say x equal to sin x, okay, sin x और minus sin x, okay, दोनों का भी amplitude कैसे होगा? If it is sinusoidal wave, its amplitude is also 1. Okay, if it is minus sin x, okay, this is, let's say, sin x. Minus sin x means you multiply minus 1 with this. Okay, so it is just opposite. Okay, but still minus sin x, but still how much is the amplitude in the second case? Minus x sin x में amplitude
1.
1, because you are taking the positive peak. Okay, so that is also 1. So here in the second example, the amplitude will be 2. Okay, I hope all the things you can calculate. The amplitude is 2 volt. Frequency you can calculate omega 0, or the angular frequency is your 500 pi. Okay, because this one is your omega 0. Okay, yes, the second example is there. Second example, this phase is how much?
The pi by 4.
Pi by 4.
Yes, yes, pi by 4. Okay, so if you have calculated omega 0 or no this one, so this is equal to 2 pi f. So you can calculate f is equal to 250 hertz. Okay, okay, so I think I'll stop here. Okay, yesterday you had some of you have not renamed properly, so due to that some problem has happened, and the 2-3 students have not got the attendance properly. So today or now onwards, before coming to the class, you name rename it properly. Okay, and when you are renaming for the theory class, why are you writing K2 or K1? It is, I think, the same roll number, no? So you've written 36 K2. Okay, don't do any changes. I'm taking attendance.
सर एक ही स्क्रीनशॉट में स्क्रॉल कर सकते थे, पूरा आ जाता है एक बार में।
नहीं, मेरा ये टैब में नहीं हो रहा है। ओके, वो मोबाइल में होता है। ये आई थिंक इट
तो
इज
इसमें अभी लिखा था आपके ऑप्शन में नीचे।
ऑप्शन था, मे बी आई हैव नॉट सीन इट, आई विल चेक इट. ओके, सो आई वाज आल्सो सर्चिंग फॉर दैट, आई डिडंट गेट yesterday. Okay, anyway.
Sir,
Yes.
take doubt, sir.
Yes.
Sir, if at all a wave is not a sinusoidal wave, okay, there is a possibility that the height of the crest and the depth of the trough can be different.
Yes.
So अगर ऐसा होता है कि मतलब उसका हाइट अलग है, इसका डेप्थ अलग है, तब भी उसको हम लोग कंटिन्यूअस वेव बोलेंगे?
Yes, it is continuous. So if it is satisfying continuous, it means if it is not discretized. Okay, I mean if the amplitude is there for every instances of time, then it will be a continuous signal.
irrespective of the fact कि उसका crest और height और ये depth अलग अलग है.
Yes, as okay. Just look at this example. I mean this point. जो when you are drawing an analog signal, okay, so how you are drawing it? We are just drawing it. Okay, so this is a analog signal. Okay, so if it is an analog signal, yes, if it is analog signal here, I mean the crest is different and this peak is different. Okay, it is not same. Okay, whether it is, I mean, any other property it is satisfying or not, that is different thing. Or it's a continuous signal. Discretized or digital signal means what? The amplitude is not there at every instances of time. It is discretized in time axis. Okay.
Yes, sir. And sir, sir,
Yeah.
sir, can we have the till date what we are teaching every day? Can we have the PPT in our group, sir? Because
Yes, definitely.
Because it is very difficult for us to maintain notes while seeing and doing simultaneously. So what you are teaching, if you can have the PPT, it would be very easy for us, sir.
Yes, I'll just give you PPT. I also already prepared. I was thinking to give you some person. I mean, okay. After today's class, or maybe I mean maybe tomorrow, day after tomorrow, we'll start with semiconductor. Okay, so there are a lot of things I'll just explain in PPT. But there will be some person where the theoretical explanation or theoretical writings will be there for your exam point of view. So those persons I will prepare the notes also, and those for those persons I'll give you notes, as well as for the other persons I'll give you PPT.
Sir, while you're teaching, we all are simultaneously making notes, but some little portion are being mixed. So if you send the PPT to us, we can have a clear picture of what you have taught.
Okay, so what I'll do, I mean, not every day, every 2-3 days, I mean, one person is completed.
Yes,
okay,
sir, yes, sir.
So those persons I'll give you. Okay,
Yes,
but once one particular module is completed, I will, I mean, arrange all the things. Okay, and I'll make one module PPT, and that thing
Send
I'll
it at
give.
once.
Okay,
At once we'll
whatever
send.
I'll give you now, that is for a small person. Okay, for I mean,
Yes, sir.
for a reference purpose, you can say. But at
That
last,
is
when
only,
you
sir, yes.
at last when you go through that last PPT for one module or one big chapter, okay, that you can refer to that one. Okay.
Yes, sir. Thank you. Thank you so much, sir.
Excuse me, sir.
Yes.
In the previous example, if all the crusts are same and all the depths are same, then it can be periodic.
Yes, no, for periodic, that condition should be satisfied. I mean, if let us say you are saying, I mean, this signal is not as like a sinusoidal wave. I mean, it is, let's say like this. It is fast cycle. Okay. Then again, okay, that means the first part is exactly same with the second part. Okay, then it will be called as the periodic.
Yes, sir.
Got it? I mean, I'm not saying that for periodic
Yes,
it should be completely sine wave. This is the sine wave. Okay, this second part of sine wave. It is a periodic. Okay, but this is also a periodic. This one is also a periodic. Okay, though it is not. I mean, peak is different, and the crest is different. Okay, as well as it is not a completely smoothly sinusoidal wave kind of thing. Okay, but if the first cycle is repeated here, I mean, पहला cycle जैसा है, second cycle भी वैसा ही है. Okay, और उसके बाद भी मतलब ये continuous होगा. Okay, I mean, it should be forever. Again, the third cycle should be like this. Okay, as well as in the negative side also.
Yes,
it should be like this. Okay, then it will be called as the
same
periodic. Okay, that means the positive and negative may be different, or the signal may not look like a cyclical, I mean, complete smooth wave. Okay, it may be looking like, I mean, जैसे दिखाया फिगर में. Okay, so positive different है, negative different है. Okay, but that first period should be repeated at every interval, at a particular t interval. Okay, then it will be a periodic. Got it? Hello?
Yes, sir. Yes, sir. It is clear, sir.
Okay. Anyone else having some doubt? You can ask.
Yes, sir. Okay, sir.
Okay.
Yes, sir.
Yes. Kumar. Anyone want to ask something? Or should I end the meeting now? Yes, then if you don't have any doubt, then I'm ending the meeting right now. Okay. And regarding the lab record, yesterday's lab record, I'll give you some information in the group. Okay, just wait till that point. Okay.
Okay, sir.
Okay,
Thank you.
sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Okay. Have a good day.